All right, today we're going to look at linear functions. So let's get started. All right, so here are your state standards, and here are your success criteria. So first we need to identify linear functions using graphs, tables, and equations. We need to be able to graph a linear function using discrete and continuous domains. And we need to be able to write real-life problems that correspond to both discrete and continuous data. All right, here's some key definitions or vocabulary that you need to have. Make sure you put these in your notes. A linear equation in two variables, x and y, is an equation that can be written in the form y equals mx plus b, where m and b are constants. The graph of a linear equation is a line. Okay, this is important. Remember, the graph of a linear equation is a line. A linear function is a function whose graph is a non-vertical line. Remember, if it has to pass the vertical line test to be a function. So it can't be a vertical line and still be a function. But all linear equations are lines, and if it's a non-vertical line, it's a linear function. A non-linear function does not have a constant rate of change, so its graph is not a line. So there are functions that are non-linear, but they are not going to be represented by a line. Okay, they would not have a constant rate of change. All right, a solution of a linear equation in two variables is an ordered pair, x and y, that makes the equation true. So any x and y value that you can plug into the equation, if it makes it true, that's considered a solution of that linear equation. A discrete domain is a set of input values that consist of only certain numbers in an interval. A continuous domain is a set of input values that consist of all numbers in an interval. All right, here's a good way to look at that. A discrete domain is a set of input values that consist of only certain numbers. So if you think about integers from 1 to 5, you're going to have a dot or a point on each one of those numbers because it only represents the integers from 1 to 5. That's considered discrete. Just certain numbers are in that domain. A continuous domain is a set of inputs that consists of all numbers in an interval. So if you see a solid line shaded here with the two endpoints included, that means all numbers between 1 and 5 are included. So if you think what numbers are between 1 and 5, so the integers are represented here on the number line, but think about all the numbers between 1 and 2. So there's 1 and a half, there's 1 and 1/4, there's 1.7, 1.1, 1.6. 1.67, 1.888. There's all kinds of numbers in between just 1 and 2. And between each one of those, it's the same way. So think about all the fractions and all the decimals in between each integer, and then you're thinking of continuous domain, okay? So there's like an infinite number of possibilities here. This is discrete. There's a limited number of possibilities. Here, there's an infinite number of possibilities. So that's the difference between discrete domain and continuous domain. All right, now we're going to identify linear functions using a graph. All right, example 1. Does the graph represent a linear or nonlinear function? Okay, we just looked at the definitions. Remember, linear represents a line, okay? This is a curve. This is called a parabola. You will learn about these later this year. But this is not represented by a line. So this one is not a linear function. This one represents a line. So yes, this is a linear function. Okay, there is a constant rate of change between each x and y value. All right, identify linear functions using tables. Example 2, does the table represent a linear or non-linear function? And explain. So to go from 3 to 6, 6 to 9, 9 to 12, each one of those increases by an interval of 3. 36 to 30, so I subtract 6 again, subtract 6 again. That is a constant rate of increase for my x's and a constant rate of decrease for my y's. So as x increases by 3, y decreases by 6, Because the rate of change is constant, this one is a linear function. So yes, linear function here. All right, so 1 to 3.5, that's an increase of 2.5. If I add 2.5 again, I get 6. If I add 2.5 again, I get 8.5. All right, so my x's do increase at a constant rate. Let's look at my y values. To go from 2 to 9, that's an increase of 7. From 9 to 20, that's an increase of 11. And from 20 to 35, that's an increase of 15. So as x increases by 2.5, y increases by different amounts. Okay, so the rate of change is not constant. So for this example here, this table, this function is non-linear. So non-linear, linear, linear, non-linear. All right, the next example says identify linear functions using equations. Which of the following equations represent linear functions? Explain. All right, so remember before we talked about linear equation is going to be in the form y equals mx plus b. So if we can rewrite it, y equals mx plus b, then that would be considered a linear function. So let's look at y equals 3.8. Can we write that as a linear function? Well, we could write this as y equals 0x plus 3.8. So that one would be considered a linear function. Y equals the square root of x, we could not write in the form y equals mx plus b, so we'll mark that one out. This one is exponential, y equals 3 raised to the x power, so that one cannot be written in the form mx plus b. Y equals 2 over x. If I multiply both sides by x, that one, there's no way to rewrite that one as y equals mx plus b. All right, this one we could distribute. So 6 times x and 6 times negative 1 would be 6x minus 6. So 6 would be my m and negative 6 would be my b. So this one is linear, so we could write it that form. And this one is x squared. So even though we could rewrite this as negative y equals negative x squared plus 0, and then the 0 drops off, multiply by negative 1, y equals x squared, that's a quadratic. Because it's an x squared, it cannot be written as y equals mx plus b. So that one is not an answer. So which of the following equations represents linear functions? This first one here and this one. And that's the only two from that list that represent linear equations, equations of a line. All right, concept summary, representations of functions. All right, so different representations of functions. So you can have functions in words, and output is 3 more than the input. 3 more than the input would be a constant rate of change, so that represents a linear function. Y equals x plus 3. Again, this is increasing by 3 each time, so that one would represent a linear function. This one has a constant rate of change for both the input and the output. This one as well has a constant rate of change. And this one, rise 1, run 1, rise 1, run 1, rise 1, run 1. A constant rate of change is seen between each of these, so there are multiple ways to see functions represented. You do need to be familiar and aware of the different ways you can see functions represented. All right, so the easiest way to look at this is about to make a table. So we know that the equation is given, y equals 15.95x, and we know that x is the number of tickets that you can buy, and you can buy a maximum of 4. So you could buy 0, 1, 2, 3, 4. So let's go ahead and make a table. and then we'll start. So I made a table where it has your x's, and it has your equation, 15.95x, and then it has your output. So take each one of these and just plug in your x and get your output. So go ahead and complete the table yourself. And then your x and your y together give you your ordered pairs. So once you complete the table, then we'll decide if this is discrete or continuous and explain. And then we need to graph the function using its domain. All right, hopefully you took time to complete the table. You can see that 15.95 times 1 is 15.95. $15.95 times 2 is $31.90. 15.95 times 3 is $47.85. And 15.95 times 4 is $63.80. Then I just took the input and the output, and that gave me my ordered pairs. And I can say that this is discrete because you can't buy half a ticket or part of a ticket, okay? So it's going to be only these values will be the only values you can have, which makes it a limited number, so it is discrete. And that's kind of why it's discrete, because you can't have a half a ticket or whatever. All right, then it says graph the function using its domain. So if you take and use the domain 0, 1, 2, 3, 4, you plug that in, you get your output or your range. Your domain and range give you your ordered pairs. If you graph these ordered pairs, you can graph the function to see that it represents a line. So when you graph these, you can see that it is discrete. They're just points. It's not a line that includes everything in between the points. So it's just dots on the graph, and it does represent a constant rate of change. So it represents a line. So it is a linear function. So find the domain. We did that. Is the domain discrete? Yes, it is. Graph the function. We did all parts of A and B.